Hello to all the viewers. I'm Sijit, and today I will present my review paper topic on thermite welding procedures for cathodic protection system. Let me begin with the core message from the abstract. Thermite welding creates vital electrical connection to protect underground pipes from corrosion, but small mistakes like using wrong materials or skipping tests can cause failure. This review paper includes a guide following ASME and API standards with checklists to prevent errors. When the job is done right, thermite welding extends lifespan of underground pipes by decades. So why thermite welding matters? Imagine underground pipelines silently corrodes until they leak. Thermite welding stops this by bonding anodes to pipes, creating a protective electrical circuit. It is affordable, portable, and does not require electricity, perfect for remote site. But as per API RP1632 warns that poor welding compromises the entire system. This paper aligns the theoretical standards and practical application by first clarifying thermite welding variables as per ASME BPVC Section 11. Secondly, establishing a structured thermite welding workflow. Third, present real-world case study with checklist of thermite welding works in cathodic protection system. This review paper provides a guidance for doing the thermite welding correctly. It includes important documents such as WPS, PQR, flowchart, and checklist. These documents allow technicians to understand thermite welding easily and minimize welding defects. Welding Procedure Specification, also known as WPS, is a document that lists down all the important details to ensure consistency in quality and reliability. The parameters includes the base metal compatibility, thermite charge, type and quantity, mold design and preparation, preheat requirements if applicable, ignition temperature and methods, cooling and finishing procedure. Next is the Procedure Qualification Records, also known as PQR. This is to record the proof of works. This document records the specimen at workshop to prove the validity of the weldment before executing on site. The parameters include base metal specification, thermite mixture composition, mechanical testing, sample examination, electrical resistance validation, heat input calculation, and finally material certification and traceability. Thermite welding is critical and requires strict process control. Figure 1 are the process control that will directly impact the weld strength and electrical conductivity of the CP system. This flowchart guides technicians through the critical steps. In the real-world application, thermite welding will be prepared using a thermographic mold with certified thermite powder materials from recognized manufacturers. Next, perform surface preparation to minimize defects, preheating molds, and using measured thermite charge, all while wearing proper PPEs. Even with perfect execution, microcracks may occur under the surface, and it is difficult to determine under visual inspection. So, verification is critical. The The gold standard is using PAUT, which is one of a ultrasonic test to detect the internal defect. When PAUT isn't available, electrical resistance tests with a calibrate multimeter must be confirmed the connectivity below 0.5 ohms, as this is a key requirement in the API RP1632. A compliance checklist is important to ensure quality welds. Some research shows that projects using document system with checklists manage to cut down rework and defects. This checklist includes all the necessary information regarding thermite welding works. It transforms standards into actionable steps and prevents common errors like wrong material mixing or skipped electrical tests. In conclusion, thermite welding plays a critical role in maintaining reliable cathodic protection for underground piping networks. When performed ASME BPVC Section 11 requirements, these welding methods enable engineers to create approved welding procedure specifications that effectively mitigate corrosion threats and extend infrastructure service life. These studies present a systematic approach to qualifying thermite welding procedure while identifying frequent industry challenges and providing practical solutions to ensure welding quality and compliance. Lastly, I would like to extend my sincere gratitude to UTM and the research methodology course for equipping me with the foundation knowledge and guidance essential to this research report. So this is my reference list. If you have any question, feel free to comment the chat box below. Thank you.